see the whole picture.
All right.
Welcome everyone to today's session. I would like to send an apology on behalf of Dr. Josue's commitments. So I'll be taking you through the presentation on her behalf. So which means that there won't be any demonstration. So I'll just do the presentation. And then we move to the Mooc portal, which Tumelo is going to demonstrate. Then we move to question and answers on the session. Okay. No, you have to wait for me to say next. Go to the first slide, slide 3. Okay. Welcome to ISET Robotics M1. On Monday, we did Unit 1 of M1, which was components and building chassis. Tuesday, we did Unit 2, which was programming and movement. So on Wednesday, you did problem solving. So today, we are going to be focusing on attachment. In this case, we are talking about passive attachment. Next slide. Some of the navigation information. This is an ISET live online learning platform. So recording of this platform, you'll get them on the ISET Mooc 1 2022. And for any Mooc queries, you send an email to ISET@UNISA, then Tumelo will assist you in those queries. And for general queries, you send them to Anzani at ISET@UNISA, which she also assists you with the queries. Then the content of basic session will be available also on the Mooc portal. At the Mooc portal, you have to look for Mooc 1 2022, ISET Robotics M1 2022. Next slide. Okay, welcome to the journey. It's an amazing race. Be patient, and there's 4 sessions, and we are taking ISET Robotics Basics. General culture of the class. The purpose of these sessions is to equip coaches, mentors, educators, and facilitators to actually coach teams and prepare them for competitions. And questions have to be asked. There's always a question and answer session at the end, and recordings will be available on the Mooc, and people are actually requested or being required to actually register for ISET Robotics Mooc, and that is the Mooc portal link that you need to register. So the vision from basics to beyond, an overview. So we talk about engineering and programming and 21st century skills, which includes problem solving, creativity, innovation, critical thinking, imagination, collaboration, computational thinking, and 4th industrial revolution skills, as we speak of the 4IR in the current days. So we're going to build a robot using the robotics kit EV3 or Spike Prime. The EV3 is the version that was being used in, I think it was launched in 2012 and still in existence. You don't have to throw it away. But recently in 2019, there was another version called Spike Prime, which was introduced into the picture, but the components are actually more or less the same, and they can also teach the same concepts. And then you have to download the free software there, which is the EV3 software and the Spike Prime software. They're actually free online to download. Now we're going to start with motorized robot. You must remember I'm on the phone, so just take the whole slide in so that we are.
Can we hear you, Kabila? Are you still there?
So sorry about that. I had to find a corner. Somebody just came back from school. Yeah. So we are going to be in Unit 4. We are going to be talking about engineering design process, types of attachment, passive attachment, powered attachment. Remember, passive, you don't need to connect it to any motor because it doesn't need any power. So powered attachment, that's when you're going to be connecting it to a motor because they need power to actually perform something. And we also have useful resources for design and building attachments. So the engineering design processes in globally, these are the steps that you need to follow when you look at the engineering design. You have to then name the steps of the engineering design process with an example of a building requirement for any engineering design. It does not even matter if it's a robot or building or vehicle. These are the steps that you need to follow. So the names of the steps of the engineering design has to be there also. Give examples of the programming requirement. Give example of the constraint that may be needed considered during the engineering design processes. You have to give examples of the risks that you need to consider during the design processes and explain the application of the engineering design processes for each and every unit or process that you'll be building. Next. So when we build objective unit 4, to build a bumper, it can either be straight or it can either be a V shape or an invented V shape through a plow. So these are the designs that you can build. But in this way, when you talk about a bumper, when you say straight V shape or a plow, we're actually talking about the non-powered attachments, which are your passive attachments. And the function will be to deliver a deliverable. You have to build a deliverable box to deliver something. You have to build a motion trigger. You have to build a box trap. You have to build a sweep. You have to build a hook, a single or multiple prongs, and you have to build a cannibal. Carabinier. Yes. Next.
This is the next slide.
So the program objective of Unit 4, to push with a bumper, to push with a delivery box, to dump with a motion trigger, to collect with a box trap, to collect with a sweep, to collect with a hook, and to collect with a carabinier. I believe these are the tasks that will be given in the Mooc M1 Unit 4. So these are the processes that you need to do. If you can just click on that case as well. Yeah, thank you. To build and program activities of Unit 4, push with a bumper. The programming will be required a power depending on the weight of the item that you'll be pushing. Either it can be an incline or texture of the surface, but you will need power when you program depending on the item that you'll be pushing. Push with a delivery box. To push with a delivery box must not touch the wheel or and the delivery box must not touch the wheel and the bumper movement. Must not touch the wheel and the hamper movement. So when you build the delivery box and you do the program, you must make sure that when you attach it, it is not touching the wheel or the hamper movement. Dump with a motion trigger. So to dump with a motion trigger, the robot must move forward. The height of the trigger and the obstacle must be the same. The robot must be paused before reversing. So that means when you dump with the trigger, that means the robot is going to be forward with the same height as the trigger, but when it gets to the end, you pause it so that before it reverses, it can actually dump the obstacle or whatever that you are required to dump. collect with a box or a trap. The trap must be enclosed with an item. That means it must have something that is enclosing in the front because you are going to be collecting. Collect with a sweep. The robot must have a power, and a sweep must have the robot must have the power to sweep the item. Hook with a hook. The robot must slowly approach the item. That is how you must approach it. Hook with a carabiner. The robot must hook the item as quickly as possible so that it can be locked inside or hooked inside. Okay, this is the Mooc portal, which Tumelo will explain after the presentation on how to log on and get access to the Mooc portal. I think Tumelo, if you can move to the next slide because we'll address the slide. This is the end. Tumelo, that's the last slide, or if so, then you can take them through the Mooc portal and then we take question and answers. Thank you. Tumelo?
Can you hear me now?
Yes, we can hear you now.
Yes, I was saying that was the first part of the presentation. There'll be a second part as well. Let me just
just move to the second part so that
yeah.
you do the Mooc portal at the end.
No problem. In the meantime, if you have any questions regarding the session, please don't hesitate to send them on the chat box. We'll certainly attend to those questions while we're waiting for the PowerPoint presentation to be loading. We've got 3 slides for this one. Let me quickly share my screen. And yeah. Can you see my screen?
Yes, we can see the screen.
Just waiting for it to load so that I can share.
Yes, we can see the screen.
Thank you.
So on this slide, we're actually going to be focusing on the engineering design processes, which is abbreviated as EDP. Next slide.
All right. It's just loading for now. Load shedding is disturbing our network issues. So.
Are you still on campus?
I'm still on campus, yes.
Because I heard you had load shedding in the morning.
Yeah. You can go now.
Give the whole screen. Remember now, I'm using the phone. Then if you are going to be pressing, then it will be delayed. Okay, these are the all steps or principles of engineering design. So you need to ask questions, you need to imagine, you need to plan, you need to create, you need to improve, and you need to ask questions. And all these processes or steps are equally important. No one is important than the other. So that means that when learners or teams design their robots or solutions, they need to be inconsiderate of all these steps. So like when you say they must imagine what are the possible solutions and brainstorm the idea and choose the best one. That is always the first step, to actually brainstorm as a team and come up with the best solution, because as team members you'll be coming with different solutions, but as we brainstorm, you'll actually come up with the best one. Then you need to plan. Planning, remember, if you don't plan, you're actually planning to failure. So you need to plan. By planning, that means you need to draw a diagram or process maps of what you are going to be doing and make a list of materials that will be needed. So it's more like you're going to be making an inventory of things to be considered for that particular mission or project. Then you need to create, you follow the plan and create something to test. In this case, we'll be talking about maybe coming up with a prototype to actually test if this can actually materialize. Then if you come up with a prototype or design that works but needs some improvement, you actually have to come up with ideas and innovative ideas that you can actually make your original model improve and perform better. And lastly, you need to ask questions of what is the problem, how we approach it, and what are the constraints or challenges that we came across, so that they are avoided in future. Here too fast there, I missed the whole slide. Application of the design process. Design of the robot attachment and the robots too. That means when you design your robot, you must also be considerate of the attachment that you'll be putting onto the robot, so that when you don't finish your robot and then you find that there's no space or there's no arm to actually put your attachments on. So designing your robot, that means you are designing the robot in consideration of the challenge that is given, and also considering the types of attachment that you're going to need to actually accomplish the challenge. And a number of examples of attachments are presented. So I think in your Mooc portal, there are different types of attachments that you can get, and you can actually go and visit them and prepare for your challenges. And okay, for designing of your attachment, you need to download and install Lego Digital Designer, which is a free software that you can download onto your laptop, which actually can assist you for those ones without physical robot. You can actually build robots and have attachments on that portal. It's actually a simulation platform whereby you can build your robot and even attach them, put attachments to them without actually having a physical robot. So below there, it's actually the different types of attachments that you can actually build. And in this case, they are only demonstrating your passive attachment, which don't actually need any power or motor attached to them. And these are some of the useful resources that you can use to build your attachment. These are booklets that you can actually download. I know that the winning design booklet comes in. I'm not so sure if Spike Prime has already it, but I know that your NXT had a version of it and the EV3 also had a version of it. So these are the booklets that you can actually look for ideas in terms of building your attachments. Why do we need attachments? Consider the verbs. So you need attachments to pull, you need attachment to push, you need attachment to collect, you need attachment to deliver, you need attachment to lift, you need attachment to drop, fetch, items of various shapes and weight. So your attachments are needed to be added to a robot, should be easy to extend types of attachment depending on the design of the robot that you have built and the challenge that you are facing. So passive attachment are actually in M1, and powered motorized attachment, you'll actually find them in Mooc 2. So in Mooc 1, we're only talking of passive attachments, meaning attachments which don't require power or which don't require a motor to be attached to them to perform things. So example of attachment, they may clip into a larger chassis, maybe large attachment for really small robots. Passive attachment means there's no additional programming required. Powered attachment means that there is additional requirement, the additional programming required, because in this case you will need to have an additional motor attached to a robot so that that motor can be programmed to perform a certain task. And below are the YouTube links that you can actually look at. Introducing passive attachment. Passive attachments, there's no additional power of motor or programming required. Allows the robot to push, pull, sweep, drop, collect items, as we're speaking throughout the presentation, that you are going to be collecting, pushing, sweeping, or hooking, etc. It should be easy to pin on a chassis depending on your design. So that means when you design a robot, you must be considerate of the types of things that you'll be collecting or pushing, so that it will be easy to actually put your attachment together. And examples are your bumper, floor, container, and hook. Designing attachment. Explanation. Follow building instructions. It says, add a clear task, learn what to do. On the brainstorming and design, foster creativity, teamwork, and problem solving. Again, on explanation, add on, it's fast and straightforward. And on exploration, it can be intimidating and fuzzy. It actually eliminates lack of ownership. On the exploration, it actually adds ownership of a product. On the explanation, it eliminates design. Designs might not be suitable for a given task, and also it eliminates time consuming, needs good troubleshooting skills. Apply existing knowledge. There's no need to reinvent the wheel. Expand knowledge, expand creativity. So this is an example of a triggered attachment where your robot needs to go forward, put a pause so that the ball they can just fall into the bucket. So you program your robot to go forward, put a pause before reversing, then the ball will fall into the bucket. So this is an attachment that you will be building if you are to push and drop something somewhere. It's a straightforward attachment because you just put everything into the attachment and you just push them forward. So you can also use it to collect. So this is next slide. So in these examples, is an example whereby you put a bumper attachment that is used. So this is when you have to push things forward without actually carrying them onto the side. You just push them forward and let it go. So the another type of an example that you can use there is a V-shape attachment and a plow attachment, because in this case you are just pushing something forward and then reverse it. And these are all the useful resources that you can actually use to actually build your powered and passive attachment. So they are available free online, and these are the videos that you can also look at for different competitions which robots were competing. Next slide. And your homework for today is that the homework for today is that you should go into the Mooc site, and on unit 4 you need to complete all activities, submit M1 portfolio, and complete M1 for evaluation, because this is the last unit of M1. So you build attachment and test them, and we're glad we have this time together. And for any queries, you can send an email to isat@unisa.ac.za, or you can always reach out to Dr. Host at hostpm@unisa.ac.za. And I think this is the slide I'll hand over to Tumelo to take you through the Mooc portal for those who are still struggling to log on to the Mooc portal, and also open for question and answers. Thank you.
Thank you so much, Gavelo. For those of you who are joining us for the very first time, or for participants who are regular, I'm just going to ask you a question so that we find out whether are you registered, or are you registered for the Mooc portal? That it's much easier for us to know where we are. And then for those of you who have questions, feel free to ask. Yes. So for now, let me just share my screen for those of you who are new to this. Yeah. So I hope you can see my screen. Please confirm, Anzani, whether you can see my screen. Yes. All right. So as you can see there on the chat box, I showed you the link of the Mooc portal. So this is the link for the Mooc portal. And then if you are new on this link, underneath the UNISA logo, there's a welcome and how to register. When you click on how to register, it will show you a PDF. So this PDF document, it's instructions on how to register for a Mooc portal. So step 1 is to go to the UNISA Mooc portal, where you'll find the link. And then step 2 is to create your own Mooc account using the following. So immediately when you click on new account, this is what you will find here, whereby you will be required to have your own username and fill in the following information, and as well as create your own password. As soon as you are done, you will have to enroll for a Mooc. So for the purposes of this presentation, I'll show you how to enroll for a Mooc For example, if you have already created your own user ID and your password, when you click on login, this is what you will see. It will show you an overview. So immediately when you click on membership, this is underneath the UNISA logo. When you click on membership and go to joinable sites, when you go to joinable sites, it will show you the current Mooc sites that are available there. So because I've already joined the ISET Mooc portal, it won't appear here. But for you, if this is your very first time, you will have to scroll down and look for the ISET Robotics M1 2022. And then immediately when you click on it, this is what you will find there. You will find an overview of the Mooc portal, whereby you have a nice introduction there. So as Kabelo was mentioning on the presentation, the aim of this Mooc is to equip educators, students, as well as community leaders to coach and to mentor teams of learners in robotics, and to explore and discover the exciting world of robotics. No prior knowledge is required for this Mooc. The M1 consists of 4 online units. Each unit has learning material and then ISET Robotics Live Online Learning webinar, which you are part of. Additional materials are included and recommended as well. The M1 Mooc is available from February till 30 November 2022. This is to ensure all registered students are given the opportunity to submit all the requirements of completion for the M1 Mooc. Otherwise, another challenge that you might experience, for example, when you click on Unit 1, for those of you who are already registered on the site, you might experience a challenge whereby when you want to start answering the following multiple choice questions, for example, on M1 Unit 1, you will first have to honor the honor pledge. I'll neither give nor receive aid on this assessment, and then you click on begin assessment. So please note that you are given time, which is 30 minutes. And if you have answered the following question, it is encouraged not for you to click on save, but to click on next. The reason why we want you to click on next so that you can continue, because there's an error page that you might see. So if you do see an error page, whether you have clicked next or save, you are encouraged to go to your history book or your clergy book, whereby you clear all your history so that you can start all over again. And then when you log out and then you start again, it wouldn't give you any problems regarding that. But otherwise, that's it from the Mooc presentation. Over to you, Kabelo. Thank you. And if you have any questions, please don't hesitate to post them on the chat box. Anyone, any questions? I see no one has any questions from my side, Kabelo.
And then Anzane or yourself can close the session, then we meet each other at 4.
All right. Thank you so much, Kabelo. Thank you so much, Tumelo. And then thanks as well to all our participants for joining us today. It's been a great session. And again, see you at 4 o'clock if you'll be joining the 4 o'clock session. Otherwise, have a great Thursday and see you again on Monday. Thank you.